We will discuss routing algorithm. You can write subheading routing algorithm. Subheading routing algorithm. And that mention two methods. Distance vector routing algorithm. Number two, link state routing algorithm. We will consider the distance vector. It is more easier to understand. That here the word distance means the first metric value. It could be distance, it could be delay, it could be bandwidth, whatever, right? Distance means the first metric value. First metric I think you are familiar, right? What are the typical first metrics? Hop count is one, time delay is another, bandwidth, latency, throughput. The various, I think in the diploma I gave you a full list of first metrics. They used to find the best path, right? So that part you will have to refer from the diploma note, right? Because those are coming actually for the exam. Very difficult to identify whether the question is coming from the diploma area or advanced diploma area, because it's a combination. So when you study this, you will have to study this in combination with the routing theory we have done in the diploma. And so first metric kind of things, the table I gave you earlier, the list, please remember by looking at that. Right? So here distance means the first metric value. Right? Distance equals value of the first metric. Typical metrics should be, typical metrics are count means the number of routers you have to jump over. Then delay, bandwidth, throughput, delay, bandwidth, throughput, reliability, congestion, communication first, path length, etc. Path length, etc. So distance, the word distance could mean any of these things which have been selected. Right? Vector means the direction, the output port to which the packet should be directed. Distance vector. Next line you can say vector equals, vector means direction to which datagram should be sent. Direction to which the datagram should be sent. Within brackets, the next router. The next router and output port. Next router and the output port. And in this method, if you are a router, you will be getting information from directly connected neighbors. Their routing tables will be given to you, and that happens at regular intervals of time. Normally, as I mentioned earlier, every 30 seconds, neighbor routers will be sending their routing tables to you. So you have to use those routing tables to find out how to send packets to distant places, other routers. Can write in this method. Closest neighbor router, that are directly connected. Closest neighbor routers that are directly connected to a given router that are directly connected to a given router. We will send their routing table. At regular intervals of time. We'll have to do the calculation. Combine the information of the three routing tables to make your own routing. Right? Then the router will combine the routing information of those routing tables of the received routing tables of the received routing table to prepare its own routing table. We do an example calculation to understand this. This 2005 question is that we will try to understand how to do it. Say there is a router I directly connected to 4 routers. Diagram is not drawn, actually they have discussed it and I am just drawing the summary. This may be connected to various other parts, we don't know. Four routers are directly connected to router I. We have to do a calculation in that question. This is 2005 December. Right? In the question paper you will find the question, read it. I am writing the summary here in the form of a diagram. Right? And it says delays measured are 8, 10, 12 and 11 respectively. Router I has measured these 4 time delays as 8, 10, 12 and 11 respectively. How will the router measure these time delays? Using what command? String command. It's the echo command. It says, it gives the packet, say echo it back to me, find the total time delay and divide by 2. So therefore each router can measure the time delay to the next router by using the echo command. And what is the protocol in which echo command is available? ICMP. We did it last week. ICMP. Not far away. Last week we wrote the full list of ICMP commands, and you might remember one command was echo. And I showed you echo on the screen. We send the packet by ping. Ping is the command, and then I showed you the screen coming. It echoes 3 times. Using that, delays can be measured. After that, you can write the 4 routing tables it has received. 4 routing tables it has received. Are given below. Directly connected neighbors, those 4 neighbors will send 4 tables. are looking at time delay, not the distance. These are reports coming from the other port. Right? And for this distance vector, the distance means the time delay. Time delays are the ones these routers use as a metric. I'll read each column for you. Time milliseconds. 0, 12, 25, 40, 14, 18, 17, 20. Second column you can write from the top 24, 36, 18, 27, 7, 31, 20, 0, 11, 29. Third column, capital G column, 20, 31, 19, 8, 30, 6, 0, 14, 7, 9. Last column, 21, 28, 38, 24, 22, 31, 19, 22, 10, 0. Okay. Those are the reports you received. Four reports you received. Exercise. The question is, compute the routing table for router I. Compute the routing table for router I. We directly compute. The computation has router I will have 3 columns. So you can write answer. There will be 3 column table. First column you can say destination. First column destination. Second column cost metric. Destination. Next router. Destination, then next router. Third column cost. Destination, then next router, then cost. 3 columns in the routing table. based on this record. Destination, suppose the destination is router A, router B, router C. Likewise for all other routers, you must have an entry here in the table. Can you prepare it up? To all the routers in the table. First one is very easy. From I to A. I to A you have method. You don't need to take those into account because you have method. You are I. You have method. You can directly say next router is destination is A. There is no next router. You can directly go to A. Up to 8 milliseconds. Likewise, for these four, can you directly, for the router H you can enter 10, E you can enter 12, J you can enter 11. Can you directly fill those four because they have been already measured by yourself. So they are directly known to you. Corresponding rows in the table now, you can fill. So for values you can directly put. That means 4 rows in the table are already pre-calculated by you. If you like, you can enter them with a different color to note that because they are precisely known because you are the one who measures them according to the question. Then for router B. For router, to reach the router B is not directly connected to you. You don't know where it is. Because the topology is not known, you don't know whether router is this area or router B is here, there. You don't know. Because the whole topology is not known to you. But you believe in these signs which others are sending. So what you have to do is, you have to read this row. And find which router gives the best path for you. What are the values there? 12, 36, 31, 28. If you want to go to router B, which of these 4 routers would you select? Would you like to send it to A, H, D or J? You can directly say. Why? Because these are also there. Capital A says it can reach B within 12 milliseconds. But to go to A you need another 8. Altogether 12 plus 8, 20 milliseconds will be required to do that. All others are higher than 20. Therefore, definitely, this must be the best way. You are forwarding to A. So the next router should be A, then it should be 20 milliseconds. If you like, you can write a little explanation below the table how that 20 came. In fact, from here you get 12 plus 8, 20. From this you get 36 plus router B. Router H. To go to H you need another 10. 36 plus 10, 46. Here 31 plus another 12, 43. Here 11 plus 28. 29. Maybe below the table you can explain those 4 calculations. 20, 46, 43, 31. shortest is 20. Lowest delay is 20. That is via router A. Since we can't write a note for this, I would like you to write something for you to understand this calculation later. Otherwise later you might wonder how these values come. Just write one example for router B, one example, that will be enough. Other stuff in it. At least one example you better write, otherwise later you will confuse. We will repeat that calculation now for all others. Router C. You are router I, you want to send something to C. C is not directly within your C. So you have to believe what the others say. This is 25. Look at the forward is 25, 18, 19, 38. Because here you get 25 plus 8, 33. 18 plus 10, 28. 19 plus 12, 32. 38 plus 11, again more. Therefore it must be the... So you decide to give the job to H. So packet comes saying I want to go to C. You will forward it to H and H will do the rest. Actually, you don't know where about. Whether it is giving it direct or via someone else, you don't know. Because you are not supposed to know about topology. Likewise, can you repeat for D? For D, we will compare the answer. Is it G 20? G with 20 milliseconds. For D, forward the next router is capital G, total time is 20 milliseconds. So capital E, H70, H70. Right? So capital F, G80. Capital F, G80. Capital G12, H10. I, there is nothing, dash. I to I you are not sending. J is 11. Can I repeat? First one A 8, B A20, C H28, D G20, E H17, F G18. Others are all direct measurements. You already know that, right? G is 12, H is 10, I is dash, J is 11. So for the moment, this will be the routing table for I. This will be the routing table for I. In fact, I do this calculation, capital I do this calculation without knowing where these routers are. It believes what the neighbors are saying. So you can write. Note that. The router capital I does not exactly know where the other routers are. Not exactly know where the other routers are. Because the topology of the network is not published. Topology of the network is not published as routing information. Not published as the routing information. It believes in the four neighbors. It believes in the four neighbors. In this example, was the time delay. Vector or the cosmetric use was the time delay. For other metrics, method will be similar. For other metrics also, the method will be similar. For other metrics also, the method will be similar. This algorithm is known as Bellman-Ford algorithm. B-E-L-L-M-A-N. Bellman-Ford. F-O-R-D. Bellman-Ford algorithm. Full kernel FQL KUR KER Ford full kernel algorithm. Algorithm U with RIP routing protocol. RIP routing protocol. RIP. Routing information. We'll write a little bit about RIP also because the name came. Subheading you can write. Write a subheading RIP. you can say. We'll write in point form. The first point is made use of distance vector algorithm. Distance vector algorithm. And in 1982, this algorithm was built into Unix. Operating system, very popular. That is BSc and Berkeley Software Distribution. If you go to Berkeley University, this is freely downloadable and one of the most popular operating systems and the earliest one. Most of the servers run on Unix BSc. In fact, in our university, 100% of servers are running on Unix BSc. Basically, all universities. Because it was developed for universities, but it's freely available for anybody if you want. It's called Berkeley Software Distribution because Berkeley is the university which developed this operating system long time ago and still remains popular. But the problem is you have to learn a little bit of typing. So it's not that very painful. If you are used with the Windows, for example, you are already maybe familiar with graphical user interface, but Unix is not that friendly like graphical user interface. You need to type few commands to get things done. Then why do people use Unix? Because the GUI is much easier. Are these universities crazy? One reason it's free. It's not for money. Secondly, it's highly stable, very, very stable. It does not crash. Basically, our servers, they never crash. I don't remember a crash unless there is a big power failure. When the battery drains, it crashes. But other than that, difficult to crash. Reliability is very high. So free and reliable in other words. Better. Free from attack. Nobody wants to attack free software. Therefore, no virus. So those reasons make the server. Now, if a server is attacked, you know a lot of problems. You have to set it up again. And in the university, people don't have that much of time to go after and look after this every day. So what we do is we load the FreeBSD and just boot it up and it runs. We don't have to look after it. Therefore, it's one of the easiest ways to run server. And RIP was built into that in even as early days as 1982. Third point, routing metric is the number of hops. Routing metric is the number of hops. Within bracket hop count. First, maximum is 15 hops. Maximum is 15 hops because it has a 4-bit number field. So it has a 4-bit number field. Next one. Next point. Each router maintains a list of possible destinations router maintains a list of possible destinations and they are vectors in the routing table. They are routing tables. Next point. Once every 30 seconds, the distance vectors in their routing table are exchanged with the neighbor. Distance vector means this distance vector. For example, capital A says it's like a ball. Okay, I can reach C within 25 minutes. Distance vector. Distance is a vector. You have seen this distance vector by the road, right? Road sign. It says parallel 2 kilometers. Like that, you have seen the distance vector. They are the distance vector. And all these we are writing here are distance vectors. Capital A says I can show how to go to B within 12 minutes. That's the distance vector. So the routing table consists of these distance vectors. They are exchanged with the neighbor. Okay. And every 30 milliseconds, once every 30 milliseconds. But if it is not received within 180 milliseconds, it considers that other router is out. Okay. Next point. If the routing table from the neighbor was not received after 180 milliseconds. Was not received after 180 milliseconds. Sorry, 180 seconds. 180 seconds. It decides that the neighbor router or the link is dead. So the link is dead. So those are the basic properties of RI. But it has two problems. One problem is too much transmission over the wire about this routing information, because your bandwidth between routers get occupied because of these routine messages which go. Even if the topology has not changed, you continue to transmit once every 30 seconds. One might ask, why do you transmit so often? Now with the technologies like optical fiber are more reliable, the chances of them being dead is down is less now. So why do we transmit at so regular intervals? Then you are occupying the bandwidth of the line. That way the amount of information users can transmit becomes less. So that's one issue. It is called the load on the wire, load on the transmission line. Second issue is there can be loop. Loop means, for example, capital G says it can reach B in 31 milliseconds. Capital G says it can reach B in 31 milliseconds. It looks like whether capital G has a path to B somewhere. In 31 milliseconds it will go. But sometimes what capital G is saying is that capital G, because the path is not given, capital G is actually meaning that through you it can send in 31 minutes. That's ridiculous, isn't it? Because then you could have directly sent this way. Capital G says, no, when he says with 31 milliseconds I can send to B, how do you know that whether that path is through you? We assume that it's elsewhere, but because he is not saying from where he is getting that done, he may have assumed that you use it. But in that case, you don't want to send to G. That's called a loop. Loop means the path calculated by the other router is through you, but you don't know that and you believe what he is saying. Therefore, there can be loops created in this. So you send to G thinking, suppose a packet going to B came to you, you send it to G because 31 milliseconds is there, assume you selected that, and G will send it back to you because he has assumed that it's going through you, and you again send it back to G. That's a loop. That packet goes nowhere after. So those are the problems, two problems in this. Because these numbers, only numbers are given to you. They don't say from where they get it. It may be the table you transmitted earlier to him, he has calculated. And now he transmits the table to you and you believe in that and recalculate your one. That's the problem which causes the loop. Because the path is not given, only the metric is given but not the path. Unfortunately, if the path is through yourself, we are in real. Okay? You can write RIP has two main weaknesses. Number one, loading on the physical path. And that you can explain that the advertisement between routers, advertisements you advertise the routing table. Advertisements between routers take a fair amount of bandwidth. Because they take place at regular intervals of time. Because they take place at regular intervals of time. Second disadvantage, routing loops may be created. Between two adjacent routers. Routing loops may be created between two adjacent routers. Yes, you can explain. Then the packet may bounce back and forth. FORPH forth in the loop until its TTL, until its time to live, is over. Until its time to live is over. Those are the two problems. Understand, mention the reason for it. Reason is that the router never sees the map. Router never sees the map. Router never sees the map, within brackets the topology of the network. For the topology of the network. So it's like you are planning a trip without looking at the map, Sri Lanka's map. If the map is there, you know the relative position of every city, the roads and all those. But supposing you are planning without the map, you may be asking your friends, the neighbors, about their experience. They will say, okay, I went through that route, it took me this much of time, and you note down and you go. That's also not bad, you can still go. But you will never have the big picture of where you are going. But for sightseeing, it doesn't matter sometimes, because you will still see the same sight. Some people go trips without planning at all. And that is different kind of excitement. Because anyway, everything you can see is basically seen whether you plan and go or not. So therefore, this method, although it does not try to get the picture of the whole network, it works. So this algorithm is one of the most simple algorithms. It gets the job done, except those little problems from time to time. But normally it works. Only issue is, it never sees the big picture. It never sees which router is connected to which router. It never sees. It believes what the neighbors say. And the accuracy of the neighbors' words are not also sure, because they may have planned the path through yourself, which you never know. So, therefore, RIP becomes one of the most simplest protocols for routing. The other method is that you take a map. You find out where you are. You find out the destination you want to go, and you calculate what are the best paths, and then make a decision that, okay, this is the path I am going to take, because my cost metric would be the lowest here. Maybe if your concern is the money, the fuel, so you will try to take the shortest path. If your concern is not the fuel but the time, you might take the best route, which has good road conditions and all. So likewise, depending on the cost metric you have selected, you will decide on one of the routes from the map. And then, because you rely on the map, not on the neighbors, the map also has to be updated. Suppose the road is broken or something. New road has come. Somebody should update the map, survey department or somebody. But maps are not updated every day. Once every 30 seconds you don't update maps. The map will be updated normally when a change occurs. Suppose new road is constructed. And most of the maps in Sri Lanka do not have these new highways coming. So they have to update. So when some topology change occurs only, you will advertise your update. Therefore, your first disadvantage is not there. It is the first disadvantage. First disadvantage is that regular advertising of the topology, advertising of the routing table takes a lot of bandwidth. But since you are not regularly advertising now, you are advertising when some change occurs only, it occupies minimum bandwidth. And loops are not possible because you see the whole map now. And you can open circuit all loops. So both these disadvantages are overcome by using the other method. That MAP method we call link state routing algorithm, the other one, second one. So we can write number 2. Number 1 is what we did, distance vector algorithm. Number 2, link state routing algorithm. Link state routing algorithm. So that in this method, all routers topology of the network, all map within that topology of the network with all link cost information. Link cost estimation. Therefore, each will calculate best path based on this topology, based on the whole topology. To do this, an algorithm known as Dijkstra's algorithm. It's a person who found it. Dijkstra's algorithm is used. Algorithm known as Dijkstra's algorithm is used. So, it is an example of a link state routing algorithm. We'll do an example again, rather than the theory. But you can draw this arrangement of routes. So assume that this is a topology router will receive. All routers will receive this through their routing protocol. Earlier method, you have only two tables coming from the other. But in this method, everybody, if there is a change, will inform you. Everybody informs everybody. Therefore, everyone has this tag in the memory. All the routers in the network topology. We know this topology. At any given time. At any given time. Through the link advertisement. Through the link advertisement. That are broadcasted to everybody, every router. Broadcasted to every router. Not the neighbors, remember, right? Not the neighbors. Every router gets received. Underline broadcasted to every router. Link advertisements are topology change. You can write any topology change. Any topology change is immediately broadcasted. Any topology change is immediately broadcasted to all the routers. All the routers in the network. Let us use a graphical abstraction method. Graphical abstraction method in which line shows a link. Line shows a link. And a small circle shows a router. Small circle shows a router. In this algorithm, the method uses this kind of a diagram which we call abstraction diagram. It is joined by circulation. So they are interconnected. Like you are looking at the whole map of Sri Lanka. If that you are looking at the whole map of Sri Lanka and you can see the cities, you can see the roads. And also the map has the distances given in a scale. The distances are the cost. In this case the cost may be delayed, but it is like whatever distance. Those are the links for them. And if there is any change in any of this information, it is broadcasted to everybody, so everybody will update the map. So it's like survey department's job. Not like the earlier method. Earlier method is asking the neighbors, but this method is always asking the survey department. Any change will be broadcasted for everyone to update. Yes? So remember those examples I give because we are not writing them. Right? The comparisons you have to remember in your mind. Right? This is like the map method. The Sri Lanka's map you have to remember when you study this. Okay, now you go step by step, preparing your path. Right? Assume that you are router A now. You are preparing your routing. Right? Assuming you are router A, Prepare the routing table. Prepare the routing table using DISCA algorithm. Using DISCA's algorithm. DISCA, DIJKSTRA. Step 1, we call them iterations actually, iteration 1. So you have to write a program actually. This is a program which is not in our syllabus. This is a program which is run inside the router. This is the algorithm, not the programming software, but you can code it into software and load it to the router, and router is going through this in order to calculate this routing table. So we are not going to study to the program level, but we will do it in step by step. You don't need to draw it like this. I will give you a short method. So iteration 1, iteration ITERATION, iteration 1. Iteration 1 is the first step. Put a dash and select A as a permanent node. Select A as a permanent node, and then identify the best link. Best link, which means minimum cost. When you select some node as a permanent node, you normally darken it. That means you have selected that. And assume that you have selected lowest cost path. Lowest cost path from A. That's iteration 1, first iteration. That means if you want to go to D, you can go direct with a cost of 1. D is cost of 1 direct. D is the cost of 1 direct connection. So that's the step. Then, so therefore D will be a permanent node. Permanent node is your schedule. You do like this. Permanent. And then select the lowest from this. Therefore, you select that path also as your permanent node. It's like you are trying to go to Anuradhapura or somewhere and you are finding what are the routes, where the distances are shorter. Simple job. Main problem is that person's name is very difficult. And then the job is very simple. This is something you normally do. So this is one. So then you decide, okay, if you want to go to E, total cost is 2 via D. Total cost is 2 via D. And now E becomes another permanent node. Then from E you can see lowest cost again. That means to go to C, you can check all others are having higher cost. Just double check. And internet to go to C, the cost will be 1 to 3 via D. Why via D? Because A will not be directly forwarding to C, then it's 5. Via B is 5. Via D only it is 6. Therefore it has to be via D. So this will be a node which has to be connected to A directly. So you can go either via B, or via D, or via C. So therefore you select, okay, if you want to go to this city, the shortest distance is here, via this city. You have to start your journey this way. That is what it says. Start your journey from that route. That's called via D. So likewise, can you select your permanent node? So this becomes a permanent node now. From there, if you look at the shortest path, you go to F. Which path would you select? This path. This path. Because from this one it's already 3. 3 plus 5 is plus 8. But this one is 2. 2 plus 2 is 4. So you select this one. Select that path. And then this will be 2 plus 2, 4 via D. This is also a permanent node now. You have found a way. Now you have not found a way for this yet. And what is next to this way 1 plus 2, 3, this way 2, so this will be the best. That will be your last question. Now that also becomes a permanent one. Is 2 direct. Okay, now we have found therefore next out prepare your table. These numbers are directly possible now. D is 2 dash. C is 3D. Just stop. F is 4D. D is 2D. D is 1 dash. Via B you are not going to go anywhere now, right? Because even if you go this way it's 4, too much. Even if you go this way it's 5, but this way it's 3. Table is prepared by A like this by looking at the whole map now. In fact, this is the most logical way. We normally do it that way if you want to find the shortest distance. After that, these other links you make dotted line. Because they are not in your main path. They are not permanent links. So you can draw a new diagram. Use different colors for them. You don't care about these things. The red ones are the important ones for you. So these are the routes you want to go. Other routes you are not worried because they are useless for you. Now you know how to go to any city in the country. But you don't need to use all the roads now. You have identified the roads you are going to use to go to any city. And that's there is that. Now you can see loops are not there. Only a single ending. Loops are not there. So this is done by a program which is called discharge algorithm. So this is the second method of preparing routing table. You can see the full routing table. These other links are not important. These roads we are not going to go anyway. So only these roads are important for me. That's what capital A. Can you quickly prepare same thing for capital B? You can do it yourself. What capital B does, if you can do it quickly, then you have mastered the discharge algorithm. The exercise, repeat the same as done by capital B. Repeat the same as done by capital B. Shall we quickly do for capital B? Assume that you are B and you are calculating. What was that? What is it? Deal. 5? 5. triangles, right? 2 plus 3 is 5. 3 plus 1 is 4. And this is 5. This way 5, this way 4, this way 3. So you will like this. You have to use these numbers to calculate the next one. You don't have to calculate from the beginning. You use this number and, for example, if you are calculating this, this is 3 plus 2, 5. 3 plus 5, 8. Therefore, you make it over. Don't calculate from the beginning. That will take a long time. And now, these things are not used. They are not coming into your picture. Now you can see there are no loops. That's the diagram B will see. This is the diagram A will see. A will use this diagram. B will use a different diagram, you can see. Likewise, each router will be doing its own calculation and making the table. Can you prepare the table quickly, please? For B. Yeah. It will be destination. Just copy these numbers, that's all. Copy. Okay, it is 2 there. C there. D 2 there. E 3D. Likewise, for all routers, you can make the routing table, and these routers will be doing independently using this class algorithm. I hope you understood the two. Here, map method. Earlier one, hearsay method. You are asking the other people and they give a plan. Those are the two types. And this method is popular in the OSPF, open shortest path first. In fact, you are calculating the shortest path. Why do we call it open shortest path? Because there are no loops. You avoid loops. All are open. Open and the shortest path. So open shortest path first is the name given to this discharge algorithm, which is a better way than pronouncing discharge. OSPF, open shortest path first, same as discharge algorithm. So one last sentence. Similarly, all routers calculate their table. Calculate their routing table. This algorithm is used with OSPF routing protocol. OSPF routing protocol. So we discussed the two main routing protocols today, OSPF and RIP. Dispatch algorithm and Bellman-Ford algorithm. One of these two are likely to come for the exam. And it's nothing much. That question is very easy question. Okay, we call it a day. Thank you.